10.1e, factor, common factors and grouping. Grouping with a change of order. So sometimes when we have a polynomial with 4 terms and we want to look at them as 2 sets of binomials, they're kind of like in the wrong order. And I still have trouble finding things that I can factor out. And if that's the case, if the binomials like don't match and I can't find something I can take out of both of them, I can, if they don't match, I can change the order, which really means I can rewrite them in whatever order I want. I can put them however I want. So let's look at an example here, because I feel like this is something that's best explained with examples. So I have 12a squared minus 7b plus 3ab minus 28a. And if I were to break those up like we did before, there's not anything that I can factor out of 12a squared minus 7b. There's no number. There's no variable. Same with 3ab minus 28. Well, I guess I could do a, but that's not very many things. So here are some tips that I want you to think about when you are thinking about kind of moving things around. Can I group negative numbers together? Can I group positive numbers together? That's kind of one option. I like to look at things that have a common factor. So that's how I'm going to deal with this. I'm going to look at this and say, hey, you know what? There's a 7 right here. And I know that 7 and 28 like have the same factors. So I'm going to end up grouping those together, which then of course means that I'm going to group this 12 and this 3 together, those 2 terms. But again, they have the same they have the same common factor of 3. So this is going to work. The other thing I'm going to think about when I'm rewriting my polynomial here is that I probably want to do the bigger numbers first in both my sets of polynomials, or put the smaller numbers first in both of my sets of polynomials. There's no like wrong way to do this. The reason for it though is then when you get that second polynomial, that same thing in both groups that can be factored out, it looks the same. So here I'm going to rewrite this, right? I have 12a squared, and now I'm going to group it with 3ab. And then, because I had the bigger number over here, the 12, now I'm going to do minus 28a minus 7b over here, and I'm just moving those locations because now the bigger number is in front on both of my groups. Okay, let's do some factoring. 12 and 3, I can take 3 out of both of those guys. And then a squared and ab, I can take a out of both. So what I'm left with, 12 divided by 3 is 4. A squared divided by a is a. 3 divided by 3 is 1. And ab divided by a just leaves me with b. So there I factored my first group of terms, my first little polynomial group. Now I'm going to move on to the negative 28a. That's an a. That does not look like an a. And minus 7b. So again, I can take 7 out of both of these, and I'm gonna, because they're both negative, I'm gonna take negative 7 out of both of them, because then everything inside my parentheses is gonna be nice and positive. Negative 28 divided by 7 is 4. The a is not being touched at all, so I'm just gonna leave it. Negative 7 divided by negative 7 is 1. And then again, that b, nothing's happening with him, so he's just going to come straight down. And again, I don't really need this 1 right there. You can always put the 1 there if that's helpful. Okay, so now I've factored my two binomial groups within this polynomial. I'm going to take that binomial out, 4a plus b, So these are both gone. And then I'm going to rewrite for my second parentheses, everything that's left, which is this 3a over here minus 7. So even though I had to change the order and kind of mix some things around, I still was able to factor this 4-term polynomial into 2 binomials. And again, if I want to FOIL it out, first, outside, inside, last, I should come up with that same polynomial that they gave us at the top of the example. Let's do one more. Same thing over here, right? Like there's something I could take out of both 6 and 20, but there's not anything I can take out of 8x and 15y. So I'm going to have to do some moving around before I finalize my binomial groups. And first off, one thing I notice is that 20 and 15 are both, they're both multiples of 5. So 5 is a factor of theirs. So I'm going to group them together. And then over here, that leaves me with 6y and 8x, or just kidding, 6xy and 8x. And I know that, that 2 is a factor of both of them. So I'm going to start to rewrite my problem here so that I can start to factor my groups. This is going to be my new line. And then I want to think about this again too. So 6 is smaller than 8. So that means that I want to put my smaller number in front on my second set of binomials. Again, so then when I get something at the end, it looks the same in both of my groups. So I'm going to put the smaller number of that group first, and then I'm going to keep going. I'll go back over to 6xy plus 8x. I know I can take x out of both, and I can take 2 out of both. 6 divided by 2 is 4. Xy divided by x is y. Plus 8 divided, oh my gosh. 6 divided by 2 is 3. What am I thinking? 8 divided by 2 is 4. And then x divided by x is nothing. They go away. It's just 1. So there's my first. Hopefully you were like, what did you just do? Hopefully you saw me do that. Now I'm going to go over and do the second group of binomials. I'm -15 and -20. I know I can pull a -5 out of both of those. Again, I'm going to do the negative because then everything inside my parentheses is going to be nice and neat and positive. -15 divided by -5 is 3. And the y we didn't do anything with, so he just comes straight down. -20 divided by -5 is going to be +4. And so again, because we took that negative out, look at that. These two guys are the same. So I can factor those out. And then come back and rewrite for my second parentheses everything that's left. So I'm able to, using grouping and changing the order, I am able to factor this polynomial out into 2 nice and neat binomials. Let me know how it goes.